Hi everyone, this is first video for week 1, day 3. Um, so we ended by drawing a parallel between our development of trig ratios from triangles into trig functions. So the next natural thing is to ask about domains and ranges of these functions. Now recall, domain is a set of valid inputs or x values, and range is the set of corresponding valid outputs or the y values. So let's do an analysis of sine theta. Now we have this advantage of knowing the fundamental definition of these trig functions, right? They are ratios of sides of triangle. So we use that as our right triangle here. It's called this x, y, and it's called the hypotenuse r. Then sine theta is opposite, which is y, over hypotenuse, which is r. What is the least value that sine theta can take? Now, let's look at this ratio. So what happens? As y increases, sine theta increases. As y decreases, sine theta decreases. So if we want to find the least value, then let's say if y is 0, then sine theta is 0. What does a triangle look like in that case? It's no longer a triangle. It's just flat. It doesn't have a height. What is the highest value that it can take? When y is r, sine theta is 1. Because it's a triangle and this can never be more than the hypotenuse. And in that case, again, you're not going to have a triangle. It's going to be like that, and they meet at infinity. And this angle would be 90 degrees. And in this case, the angle would be 0 degrees. You can verify. Let's take sine of 0 is 0. Sine of 90 is 1. Now this becomes more obvious if you look at it as a circle. If this is the point, right? Theta, sine theta is the ratio of this height or this y value with the radius. Now as you move this point, if it goes here, then y equals r and you have maximum value. If it goes here, the height decreases. So it can also become negative. Try and do the same analysis for cosine theta. Okay. Now as this point P moves counterclockwise around the circle, the values of sine theta and cosine theta are going to keep changing, right? But you will notice that for any point P, there is going to be a corresponding point in this second quadrant where this ratio y is going to be the same. Similarly, there's going to be a point in the third quadrant with the same height and a point in the fourth quadrant with the same height. What is this saying is that if I take a circle, due to the symmetry of that circle, any point on this circle having x, y, if I go horizontally across, there's going to be another point, negative x, y. Then I go vertically down, negative x, negative y, and x, negative y. There's always going to be this inscribed square with each vertex in a different quadrant. Now the radius is always the same. That's always the radius. So if I look at this angle and I look at the sine of this angle, right? This, let's say I call this theta. Sine theta is going to equal y over r. But this is also going to be sine theta, y over r. And this is also going to be sine theta, and this is also going to be sine theta. Alright, so this is telling me that the values of sine theta repeat. 4 times for each rotation. Now over here it's going to be positive, right? Over here it's going to be positive, then it's going to be negative, negative. So out of these 4 times, 2 times positive and 2 times negative. Which means if you know that, for example, if you know that for some theta, sine theta is 1/2, then there is some other theta for which it is 1/2 and 2 other thetas for which it is negative 1/2. So any value of sine is going to repeat. If you just look at the value, it's going to repeat 4 times, but of that 2 times is going to be positive and 2 times is going to be negative. Which means that if I were to graph this function, for example, I'm not going to graph the whole thing, but if I know that this point is there on the graph, then it's going to appear again, and then its negative version and the negative version is going to appear 2 times, right? So for example, 0, we saw that sine 0 is 0. It means sine of something else is going to be 0 and sine of something else is going to be 0. Then we saw it takes a value 1, right? And then it's going to take a value negative 1. Again, any point here is going to have a corresponding point here, a negative value here, a negative value here. Okay, so it's a consequence of the symmetry of the inscribed square in the circle. Okay, so we found that x can take any value, right? That the domain is R. But then we also found that the y value is capped at 1 and it's capped down below at negative 1. So, we also found that it repeats itself in this interesting pattern of 4 times, 2 positive, 2 negative, and it follows the 4 quadrants. This behavior is called being periodic. Being periodic means the behavior repeats after a given point of time. Like our days are periodic, the sunsets are periodic, nights are periodic, all of that. And this period, or when it starts repeating, is 1 full circle, 360 degrees or 2 pi. And this makes sense because if you take this point theta, and if you look at a point which is 1 full rotation later, that would just be theta plus 2 pi. So after exactly 2 pi, you're going to repeat the values. Okay, so what's the range for sine? It's -1 to 1. What's the domain? It's R. And you should be able to reason out that it's going to be the same for cosine, which we will look at in the next video.